Hello everybody. In this video we're going to see to print circular prime numbers in a range. That means if you are giving a range from 1000 to 50,000, it will print all circular prime numbers present from 1000 to 50,000. So first of all, what's a circular prime number? If you take the number, say 3779 is said to be circular prime. Why? So if you create a rotation, that means a cycle, so making the first digit as the last digit, so this is a prime number, the number itself is a prime number. Then if you do one rotation, so 779, 3 comes to the last part, so again this 2 is also a prime number, and then I again do one more rotation, 793, then first digit comes to the last digit, so it's 7937, so it's also a prime number. Again one more rotation, and this 2 is a prime number. If I do one more rotation, I'll get the number back, the first number. Okay, so if I have all the rotated numbers as prime numbers, then that number is said to be a circular prime number. If any one of that is not a prime, then it is not a circular prime. Okay, so this is a definition of a circular prime number. So we're going to pass from and to. In that from to a range is given. Between that range or from that range, in that range it will give all the circular prime numbers. So we are planning to have these functions to be implemented in the class. These are the methods will be present in the class. Before getting to the logic part or writing the code, let us see one thing. So if I have a number like this, maybe you will be thinking whether it is a prime or not, because all these numbers are even, there is no even digit number. But if I have an even digit, say 4 is present, if I start rotating this number, there will always be a rotation which will bring 4 as a last number. Is it or not? So if I rotate, 7 comes to the last part. So if I put this one, 7 comes to the last part, then again comes to the last part, one more rotation, then again 7 comes to the last part, then 3 comes to the last part, then 4 comes to the last part. So if a 4 is the last part, that means the whole number is an even number. Even number can never be a prime number except the 2. So this is not a prime number. So if a number has even digit at any part, if a number has even digit as one of its digits, that means it will never be a circular prime number. It may be a prime number, but it will never be a circular prime, because when I do a rotation, the even number will always come to a last digit at one rotation. So that means at that time it will be an even number will be never a prime number. That means that number is not a circular prime number. Okay, so we are going to write these functions where rotate will do this rotation. It brings first digit as last digit. So I pass an integer, it will return a rotated number. isEvenDigit is a function or method. We say it gets a number, it finds whether the number is having any even digit. Even digit means 0, 2, 4, 6, 8. If a digit is even, it will return false. If there is no even digit in the number, then it will return true. So this function, it will find whether the number is prime or not. So I will pass an integer, it will return true if it is prime. Circular prime, I will pass an integer, it will return true if it is a circular prime. Returns false if it is not a circular prime. Find and range is a function which gets lower boundary and upper boundary integers. It will print all the circular prime numbers in that range. So let us implement all these functions in our case. So here I am gonna create a new class called the CircularPrime. So in the CircularPrime we're gonna implement all these. Okay, so now I'll just put a so here it gets two integers, low and int high. So between that we're gonna do. So it gets the number, it returns true or false. It also gets a num. So local variables I'm declaring. Okay. So this all these can be made as a private. So you don't want to expose these methods, just make it private. Let this alone be one which is exposed. So now I will create the objects in the intro where I got a public static void main. Both are in the same package. Okay, so it will be a is a reference variable, and we create, and we just say find in range. We can just give from 100 to say 15,000. Find and print all the CircualarPrime numbers from 100 to 15,000. Okay, so if we do that, it will come here. Okay, so in this one we are just putting int I equal to low, I less than or equal to high, I plus plus. So we are calling isCircualPrime. We will pass the numbers one by one. So if it is a CircualarPrime, we are going to print that number. So I'll just put it in a condition. So here we'll just print the number I. So loop is put up, and the loop goes from number 100 to 15,000. That is coming from here, and we are calling isCircualPrime. And if it is returning true, it will be printed. If it returns false, this will not be entered. Okay. So now if I go here, it gets the number. So first of all, we have to find does the number is having any even digit. So if a number has even digit, that means if it is returning true. Okay. So we have to just say return false. So if there is a even digit, function call has to happen. To the even digit, I have to pass this number. Okay. Even digit is a function. To that one, I will pass this number. So if it is returning true, that means if it is presence of even digit is there, means we have to return false, that it's not CircualarPrime. So if the even digit function returns false, that means we have to return true. Okay, we have to return true. That means it's a CircualarPrime, not a CircualarPrime. Okay, we'll stop this. This is not we need to do certain more things. Okay, so first, if there is a even digit, we'll return false. Otherwise, we have to find whether it is a prime or not. So let's just see. So find in range, or passing one by one here. If a number is passed to even digit finding, if it is even digit is present, it returns false immediately to this called place. Okay. Now we will write the function for isEvenDigit presence. So first we got a number num, which is stored as an integer. We'll convert it to a string. So there is a option to do that, to string. So if I pass number, it will return string to me. So this toString is a static function in the integer class. So I'm using integer class dot static function is toString. We pass the number, it will return string back to me. So that string, we are storing it in say strnum. So this is a string of the number I passed. Okay. Then we have to find every digit. We have to go through. We have to just find out whether digit is having 0, 2, 4, 6, 8 or not. So first of all, before doing that, we have to convert the number string into a character array. So there is a way to do that. Is strnum.toCharArray. There is a function. There is a method associated with this object reference strnum. So this returns a char array to me. Okay, so that char array, we are storing it in the char array. So the char array name is say charnum. Okay, so we'll have it as a charnum. So what happens is when I pass a number, it is converted to string. Now string is converted to a character array. Now we're gonna run a loop. So this loop is a collection loop. So char a, the collection name is char num. Okay, this char num variable name we're just putting. So in this collection we just find out. So here it runs through the collection. So a will be pointed to every element one by one. Okay, so if a is equal to 0, okay, or a is equal to 2, okay, or a equal to 4, or a equal to 6, equal to 8. So in this case, what we have to do, we have to return true because there is an even digit presence. Else, what we have to do, we have to return not after this for loop. Okay, when the for loop is over, what we have to do, we have to return true. Sorry, false. That means there is no even digit. So this function will do the job. So first we got the number. Say for example, if the number is the number is 3703. Okay, like this we have. So it will be having a 0. So when I do rotation, 0 will always come to a last digit in one rotation. In a certain rotation, it will be a last digit. So that means at that time it's an even number. So it will just hit this place. It will return true. That means here we are calling. It will return true means it will enter here. It will return false. This circular prime will return false, meaning it's not a circular prime. So this will be false. It will not print it. That's the flow. So here, this object this will do the job of finding whether does it have a even digit or not. Say for example, if it is returning false, that means there is no even digit present. Okay, there is no even digit present. That means what we have to do. So in our case, if we see this one 3779, there is no even digit, so it will return false here. Then what we have to do, we have to just find out whether it is prime or not. Is it or not? So if it is prime or not, we have to just find isPrime. Okay, so we have to call isPrime. So to the isPrime number, we have to pass num. Okay, so first we will write the code for prime. So here divisor, we just start with d for int d equal to 2. I can put it here. Prime or not, so it goes up to d less than or equal to num by 2 d plus plus. The divisors we are making it ready. So if num percentile d is equal to 0, that means return true, return false. That means it's not a prime number. Okay. Else once it all comes out, then return true. Okay. So this will do the job of finding whether a number is prime or not. Okay, we are starting the divisor from 2, and say if a number is 3779 is entered, it will go on dividing this number by 2, then 3, then 4, up to half of this number. The divisor goes up to that. If it is nowhere, it is not giving any remainder equal to 0, that means it returns true finally. That means it's a prime number, it will never hit it, this one. So it returns true. So once it's true, then what we should do, we have to rotate. Okay, we have to rotate it. We have to rotate. Okay, so we have to rotate. So this loop is a repetition loop, repetition thing. So if I have a while loop here, this is returning true to me means I'll just rotate. Okay, so we'll call this rotate function. We go on doing this one. So first, if it is a prime, we rotate this, and again we pass it is prime. Again we rotate it and we find it's prime or not. Again we rotate it's finding prime or not. Okay, so we'll start rotating. So rotate num. Okay, rotate num, and then we have to again we find the prime. Again we rotate. But how long we go on rotating? So when we rotate like this, one rotation, second rotation, third rotation, fourth rotation will fetch me the same number again. That means we have to stop it. So you have to check after rotation. We have to check whether it is fetching me the same or not. So after this rotate, I'll be getting it a number in a certain thing. So but what happens is we lose the number initially. So we'll take a backup. Okay, so int I equal to num. So when I'm rotating this number and I'm rolling it back, so I'll pass the number here. It will rotate and gives back to me the rotated number that is getting stored in num. So I'll have to check if num is equal to I, because we took a backup, initial backup. Before doing all these things, we took a backup. Okay, so num is stored in I. So that means after this rotation, if this is num 9377, when I rotate this one 3779, it will be the I again. So that means we have to break. Okay, we have to break again, or what we can say, we can say return. Is it CircualarPrime? Return true, because when I come back to this one, where I start with isPrime the number. Initially the number is 3779. We say it's prime, then we are rotating. So 7793. So it is not equal to this one. So it goes again prime. That means we rotate again. Again it's prime. So we rotate. We got again this is prime. It will enter here. It will rotate now. So we will be getting the same number again. But that checking has been already done for the first time itself. So that means we are return true for sure, because we come back to the same thing. We return true. That means CircualarPrime. Okay, when it goes out, when it will go out, you tell me. So if it is not a prime at some place, if it is not a prime, okay, when I'm doing rotation, in some rotation I found that it is not a prime, then we have to return false. Okay, so this is the function which does this thing, but we have to write the code to rotate. How to rotate the number? So first of all, as we done here, we will convert the number to string. Okay, so if the number is, for example, 3779, the rotation will fetch us 7793. What we have to do, we have to take the first digit and we have to append with the 779. Okay, so that means we have to cut this first index to last index. Okay, then we have to cut the first 0th index. Okay, first index 1 to last we have to cut it. That means 779. Okay, so first of all, what we have to do, extract 779. Okay, then append the first item. Okay, that first item is 3. Append with this one. Then I will be getting a string. Then you convert the string back to number. Then return it. So first we got the string of this number. So it is string format we have. So there is a one option, one method in string objects that is called substring. The substring, if you give the beginning index, it will return from that one. So you have, for example, here, if you want to see the definition of substring, there is a substring here. See this one? So here if I say unhappy.substring, from 2 it will cut. That means 0, 1, 2. From h it cuts and gives a string back to you, substring it back to you. Harbison, then I have to cut from 3. That means 0, 1, 2, 3. Bison, so it'll just cut and give it to me. Okay, so what we are going to do is we are going to cut it from index 1. So substring, we'll cut it from index 1. Okay, so that returns a string to me. With that string, what I have to append? I have to append the first item. What is the first item? This 3. So here there is one more method in the string object. It's called CharAt. So CharAt 0. So it will fetch me that 0 thing. So here we got the whole string. Okay, now I got the rotated string 7793. So this one we have to convert this one into a integer again. Okay, so there is one option called in integer class there is one option called parseInt. Okay, so for this one, if I pass a string, okay, if I pass a string, it will return the integer back to me. See this one, parseInt integer string if I pass. So here we have to pass the string, then that will be returned to us. Okay, now for example, this is the whole string we have created. So this full thing I put it here. It will return a number to me. Okay, so parse integer. So this is the substring 779. Then I'm adding 3 to that. So 7793 is a string passed and it is converted to integer. It returns. Okay, so it returns this one. So I can just put the return here. That's it. Okay, so whatever the number we pass, it will rotate and it will return it. Okay, you can store this one and you can do step by step if you don't want to do everything in a single shot like this. Okay, So first we have converted the number to a string, then we took a substring from the index 1, then in that substring we added the 0th index of strnum, so we appended, we got 7793 as a string. This string is converted to integer, that integer is returned here. Okay, now who is calling this one? It's called by this place. When I do rotate, and rotate is stored back in num. If num is not equal to I, we just go like this. Okay, so now let us see, we'll see how we'll compile and see how it is going. So we had call 100 to 15,000 we have. We'll run this one. We'll see, yeah. So 113, 131, 197, these are all the circular primes. Okay, so between 100 to 15,000. But if I put it from 10 to 15,000, okay, we'll just change it to 10 to 15,000. What are the circular prime numbers? So 11 is a circular prime, 31 is a circular prime. You can just see 31 is 13 is a circular prime, and 31 is also prime. 17 is also prime, 71 is also prime. Okay, so it's a circular prime. These are all circular prime numbers. And if I go with a single digit, so if I say 5 to 15,000, again, so if you see here, 5 is a circular prime, 7 is a circular prime. So all, even 2 is also circular prime. So if I go to 2, and then 3 is also circular prime. But what happens here, you have to see here, from 3 only it is showing, 2 is not showing. Why? Because in our place we are starting the divisor from 2. So 2 is dividing the number, so it is not taking into account. When I say 2 by 2, it is 1, so it is failing. So it returns so when I pass this number 2, what happens is, okay, so if it is 2, circular prime you are calling, so it's asking for even digit. Here it is false. You got it? So 2 is having an even digit, so it returns false, but 2 is a circular prime. So we have to take care of only these two things. So what we can do, we can write if if I is equal to 2. Okay, then or you can just put or we'll just take this one. Okay, then we can do printing. Okay, so if it is 2, then you just print it. Okay, or just go for circular prime. So it won't, if it is 2, it will come and print it. Because I am putting in the left side of OR condition, first it will check it, otherwise it won't go to the right side. So if it is true, it won't go to the right side. Okay, so 2 is also taken care of now, because 2 is a circular prime. Now it prints up to from 2 also. But if somebody just passes an integer 1 also, means 1 should not be a circular prime. That and all can be taken care of, boundary. Okay, but here it will print 1 also as a circular prime, because if you pass 1 here, what happens? It's not equal to 1, it's asking for circular prime. It does not have any even digit, so it will go for isPrime checking. So it will be 1 by 2, it will not go to the for loop, it will return true. That means it's a prime. Okay, so it's a circular prime, it will just say. Okay, so that's a problem. Okay, because when I do a rotation, I'll get the same thing, it returns true, it's a circular prime. But in case of 1, we should not do anything. So if it is equal to 1, I can just say continue, don't do anything, just continue the loop. Okay, so we can ask people to enter above 0, all the above 0 integers are taken care of. Okay, so if I give a very big number, okay, so for example, I'll give a 10 lakh. 10 lakh is the number given, so in that one, what all it is getting printed. So it is still running, it's finding and printing all these numbers, still running. See here, so it is printing up there, it is 9,99,331. Okay, so it is printing. So So we have saved some time because of this important one, because we have found our even digits. We have saved a lot of time for doing this one. If you didn't do this, if you find the prime, if you circulate and if you prime, it's a lot of wastage of time will be there. So even if I put say 50 lakh, 1 to 50 lakh, so it goes on printing, still running. So 9 lakh, still running. It will take a lot of time. It's a very big number we are given. Still running. Okay, so we had lost number we got is 9,99,331, but we are given 1 to 50 lakh. Okay, so it's huge calculations for all these. So prime finding, it takes time in here only. Prime finding, whenever there is a number which is full of odd numbers, it gets into this one, so it takes a lot of time. So we'll just stop it. Okay, we'll just give a smaller one, let's say maybe 20 lakhs. That will also take a lot of time. Still running, you can see it's in the red color. So it finished. Okay, so it finished. It's the last one is 9,99,331. There was nothing after that in this range. Okay, so this is how we have to do CircualarPrime, and how did we modelize the code, you have to understand. And these are all the toString, parseInt. These are all the static methods available in Integer. And here we had used this substring, which is available as a method. Okay, as a method in the class. These are all static methods. This is a non-static method in the object. Okay, this is a reference object, but this is a class name that you have to make sure that you are using properly. Okay, so I hope you understood this. Thank you.